Hey all, welcome to the next edition of Amnic Cast. We have Sreedhar Gade with us, and we did discuss last time about what are the areas in which you can actually use Gen AI, and we touched upon the use cases. What does SMB do? What does enterprises do? How startups can start with Gen AI. And today, what we are going to talk about is very interesting in terms of okay, you have actually like what is the use case and how do we scale that, right? Welcome, Sridhar. And why don't you give us a thought process in terms of uh, what is the difference between bootstrapping, Gen AI, and how do you scale it for production?
Absolutely. Thanks, Satya, and it's great to be back in the second edition of this series. So the like we spoke last time, I think the introduction to Bootstrap, from no AI to some AI. Now we are talking about the next level of taking it to the completely like the enterprise level of AI. So and the it's a totally different ball game. So just to give a perspective for us ourselves, during the bootstrap, we are thinking about, does generative AI even make sense for our business? What are the different use cases our competitors are using? What are the capabilities of LLMs that we can actually look at? What is the hyperscaler I can actually engage with? All these are very very basic and foundational areas. And CTOs, also engineering leaders, are still trying to figure out what's going on with the industry itself. And at the end, we kind of get the program going, bootstrap it, and then we have one or two GA based AI features already live, and there could be some private betas and public betas going in. So that is one part of it. But once we start scaling it, so the like I said, the whole game is at the next level. What basically happens is, now we are talking about, we already told our customers, we already marketed that we are going to leverage generative AI, and we are going to actually continue to release more and more features. So now we should talk about, hey, how do I get the scale, continuous scale for all the use cases that I'm going to actually deliver for in the market. And if I'm going to deliver, which hyperscaler should I actually tie up with, right? And what model should I use continuously, if I'm going to actually put, because the model could change depending upon the load that you are keeping in as well. And then I think we can actually dig in more deeper in terms of what are the different transactional aspects of it. But it is really the people, process, and technology, right? We are talking about how do we do monetization, how do you do pricing, because running on generative AI is very expensive affair. And then how are we going to monetize and then actually get the return on investment at the same level of gross margins that you had without generative AI as a SaaS product company or generic product company? So these are a lot of learnings in the market, and I think we're still learning, Satya. But I think it changes from industry, but it's very interesting to see the dynamics changing with the both modes.
Awesome. I just want to pick some of the things that I was just looking around in terms of, for example, let's take this summarization part of it, right? One is to actually just summarize of node, and we all know that okay, Gen AI does it beautifully. But then today there are apps that are coming in which is able to scale across every meeting and then amazingly able to take notes, right? Now you are moving it from, hey, Gen AI can do summary, which is more a use case, to okay, every meeting it can actually be on top of it and take notes and then send it to you, right? Now when you get into that kind of a stuff, right, how do you start planning for these production and how do you scale it?
It's a great input, and there are two aspects to this, and these are like very interesting observations I've seen at least in last 3 to 6 months of productionizing large scale LLM based use cases. The first one, like you mentioned, is we innovate on a particular use case, use a particular model, and test it out in non-production and private beta and public beta. You're already in production. Customers started using it, and then suddenly you realize there is another model which does 10x better in terms of the quality, in terms of the cost, and in terms of the performance, just because the way that LLM is built, very specific to this particular use case. And then you suddenly realize that this particular model is actually completely game changer, and you see that your competitor are already using. And that's why like I said in my first episode, it's very important for us to build. It's a it's an architecture that which is loosely coupled, right? But then like holistically integrated, which means that the code stays as is, but then you will be able to decouple a model and re-engage a different model and then be able to continue to work. And with slight differences in the behavior for the end user, but then you want to make sure that the margin of difference of behavior is within the range that most of the customers won't notice, or it's slightly better than before. So that's the first part, which is make sure your architecture is so modular that you'll be able to plug in and plug out models. The second part that I've noticed is there are certain scenarios that you don't notice when you run in small scale, maybe 10 customers, 100 customers, and you're using few million tokens. The moment you switch from million tokens to a billion tokens, or maybe 100 million tokens, suddenly you start seeing the cost goes through the roof, especially non-linearly. And you start realizing is that this is not a cost effective in a use case for me, but then I've already actually deployed this in the production. What do I do? So even in this case, we should always look for alternative solutions where, hey, if I'm using a generative AI with a token-based system, which is expensive, can I bring it in-house and use GPU-based system? So the experience that we are giving to the customer is the same, just that I'm doing it at a 10x lower cost. So I think in summary, the predictability that we had in a traditional SaaS-based system is not there in the generative AI, and that's why we should be agile and willing to make changes on the fly.
Awesome. Now that, okay, I have put my model into production, right? And then uh, built a pluggable model and everything works great. To what are some of the technical challenges and other things, that operational challenges that you have seen when you actually take it on scale, right? You have done everything, you believe everything is going, you would have had enough experience in terms of, because everybody is trying to scale for the first time, right? Like, what are some of the challenges that you have actually faced and that you could actually share?
Absolutely, there were many, and these are very practical, and these are like day-to-day stuff. So I would put them in three different buckets, which are popular buckets: people, process, technology. I'll start with the technology first. So as we scale, we start looking at, like I said initially, the what type of LLMs and what kind of hyperscalers do I use. So we have Azure giving you OpenAI. We have OpenAI itself directly giving you services. We have Bedrock, a bunch of, it's a model garden from AWS. We have Google's Vertex, and then we also have a ML library, and then there are a bunch of open source and like Llama and many other players as well in the market. What we need to continue to look at is continue to have a team which looks at these models on continuous pace and starts benchmarking and put into your shelf, so that you'll be able to actually pick them when you have a right use case there. So that's the technology part. So what is my LLM strategy? What is my hyperscaler engagement strategy? And then have this addressed within your leadership, within the technology leadership and technical architects, and then have a strategy in place. That's one. That's a tech part. The second part is the people part. You have developers, you have data scientists, but the talent for generative AI is very less, which is the data scientists who are enabled for large language models are very little in the market. And we have to use a combination of in-house grooming plus also looking out in the market and finding out how do we get a good combination. Because if we don't find the talent in time or build the talent in time, that can jeopardize your business goals on generative AI space as well.
Mhm.
So how do I make that happen? As it is, it's very difficult to kind of hire on time on like a regular developers, and this become makes the problem more exponentially complex. Third one is the process. The process has many folds, but I can tell you, for example, you have a generic legal team with you, and legal and compliance team who continuously looks for your data residency policies, your HIPAA compliance, for example, your the privacy and all the best practices that we implemented as a SaaS product, data at rest, data at transit, all that. They have to now have a generative AI wing to look at prompt safety, prompt bias, what's happening when prompt and response going towards the LLM and it's coming back. Is the data anonymized? Are we using customer data, PI data to actually train? So that's the whole different gamut of things where even the legal team needs to upskill themselves or hire. Then the AI security, AI CI/CD. So all this needs to be kind of customized for generative AI. So one good example of AI CI/CD is, so in traditional world, you basically have a development, you have test environments, you have staging, and you have production. So you have a pull request kind of created at the beginning of it, and then the code continues to get promoted all towards the production depending upon its quality and the kind of rework that it will need, or the kind of rework it doesn't need, right? In case of generative AI, it's a lot more complex. It's not
Mhm.
just code quality and security, it's also about the functionality, it's also about performance and many other areas. So the CI/CD pipeline also needs to be refurbished to support some of these use cases. So I think in summary, we're talking about people, process, technology, uh, built for generative AI to be able
Mhm.
to build these tackle these technical challenges that are associated with generative AI.
And just a follow up question on that, right? Did you have to create a platform around all these things, like, or did you repurpose? One is like you talked about CI/CD. Now there are enough CI/CD platforms already there. Versus when you are doing Gen AI, there is nothing, right? And if you have to do a different way, did you happen to do a platform engineering separately for that one?
Absolutely, yes. Especially when we're talking about scaling, we need a platform which takes care of most of the aspects that I was talking about. If we are bootstrapping phase, we could use some of the off the shelf from the market. And there are also a lot of companies, startup companies, or the large companies who are actually innovating on the generative AI are able to give us AI as service. But then if
Mhm.
you're an enterprise company or you're scaling, doing things at scale, it's important that we build a centralized platform. And even if you're doing the some of these features at a smaller scale, it's good to be doing centrally. That'll reduce a lot of duplication of work that can happen in multiple different products. So yes, we had to build this the platform ground up, but then we also took MVP approach, minimum viable product, and fail forward iterative. So to start with, the platform itself has very few components, probably like API based few components, which just does the
Mhm.
prompt forwarding. But then as we improve and learn, it got bigger and more complex, and then we started looking at aspects of not adding more latency and things like that.
Awesome. And switching on, right? Like now you create a generative AI model and then you train it, right? For example, okay, I've trained it. When I'm scaling, you will be seeing diverse amount of data, right? How do you make it adapt to a various set of stuff? Because you have the model. Now, how do you seamlessly integrate not just scale, but also adaptable to different set of data that you might see, right, from different customers or different use cases that you will have?
Absolutely. So the behavior of a large language model differs widely based on your size and type of data as well.
Hmm.
End of the day, models input is the data, and it's all garbage in, garbage out, or it's like another type of prompt that we give can like exponentially make the output come totally different. So, and that's why when we create this centralized platform for generative AI in our company, we also have some onboarding rules saying that what type of product and what type of use cases can be onboarded to start with. And each use case will have certain parameters, and one of the key parameters is the type and quantity of data that will come in with every request.
Hmm.
I'll give you an example. One use case that we can think of is sending an email to a customer based on certain ticket data. So I need to read the ticket, maybe 10 lines, and then actually create a 5 line email error and give me, I can also give you tone enhancer depending upon you want an assertive tone or a submissive tone, and depending upon customer mood, and then you can actually send it out. The whole transaction could just take maybe 1,000, 2,000 tokens for us, and customer is still happy, and we help the agent or the operator. Second scenario is creation of a technical article for an ITSM engineer. For this, I will have to probably go through 10 different wiki links and then kind of scrape a lot of data and put it all together, a 4-page document with stepwise execution, and then also kind of a flow chart. If, for example, if step 2 does not work, branch out
Mm.
to step 4, but if it works, branch out to step 3, so on and so forth. And this could probably like lead us to actually get to 20,000 tokens, for example.
Yeah.
So the output and value that we give probably the same for the customer, but the number of token usage could be like 10x or 20x. And that's why the input filters for type of data that is going in, we look at multiple different types. And this is again, the work in progress, Satya. So a lot of cases, the answers are not like very straightforward as well. Like it's like a trial and error method in most cases. But my personal recommendation for many people is have a queuing mechanism and continue to iterate. Saying that, hey, if I'm going to use 10,000 tokens, can I do it with 1,000 tokens by prompt caching or using vector databases or something like
Mm.
that? But it's very important to test this before it goes to production.
Got it. And have you also encountered, for example, you brought in tickets, right? Now, different kinds of product might have different kinds of tickets, right?
Yes.
Have you ever noticed that this kind of tickets, probably this model works? Do you have to use an ensemble of models where, hey, if this category, maybe a technology category, might have, though it's a ticket for those products, I might have to pick a different model than something else, right? Is that, do you notice something of that sort, or largely the same models are able to handle a typical use case?
So the way that we used, and my personal observation was that if you had say 20 different use cases, you could actually categorize them based on what they do.
Mm.
For example, if there are a bunch of use cases to do with responding to a customer in a customer service or ITSM portal, you're talking about text summarization, email generation, article creation, everything to do with the text is one domain. Everything to do with the code, everything to do with say a pharmaceutical company. My observation is more like the LLMs are kind of specialized in those domains than individual or like an individual use case or the domain itself.
Oh,
So, but that could, I think, happen in the future as we actually get more granular. Then we might want to actually look at a model which are tuned differently for different purposes of the same domain, which is, for example, customer tickets. But at this point, I'm looking at only at the broad categories of them since they
got it.
are called so-called large language models.
Got it. Now, coming into, let's say, what are some of the other thing, operational challenges that you have to do? For example, okay, I want to now scale it across thousands of, like, probably I was running for, let's say, 10 use cases. Now it has to be run for thousands, right? Now,
Yeah.
what are the other things? Because the GPUs are not like, it's limited, right? What are some of
Mhm.
the things that you have to think and then make sure that you plan ahead, and the challenges that you come across, so that everybody can avoid that? Okay, how do I plan to scale that?
Yeah, no, absolutely. So, in one of the my recent LinkedIn articles, I mentioned this that GPUs are the new oil. So
Hmm.
the traditional cloud promise that we all move to cloud is capacity and demand does not apply to AI. At least it doesn't apply yet, which means that including hyperscalers like Microsoft and Google are limited by number of GPUs available by NVIDIA at this point and in future, whatever they will build personally. So this is something no one foresaw. Until
Hmm.
GenAI came in early this year or last year, silicon was a commodity. All you have to do is ask for more and you get it, right? So
Yeah,
it's
yeah, yeah.
always, yeah. So in GPU's case, it's totally the opposite. It's basically
Hmm.
that you'll have to wait for it, and then whoever hoarding literally the more GPUs are the people who can actually come in the market. So looking at this scenario, I could kind of recommend in three different buckets. One is the capacity, second is the cost, third is the performance, right? So in terms of the capacity, I would recommend folks that you forecast in advance, much higher or much far in advance than we do for traditional CPUs. For
Hmm.
example, for my company, I would like to look at minimum 12 to 18 months, depending upon where my
Wow.
workloads might go,
Hmm.
and be able to block that capacity upfront. So some of the large hyperscalers are actually able to give for upfront payment or any kind of contract, they're able to kind of block your capacity, number of tokens, billions of tokens or GPUs upfront. And then I would recommend that go just block that because If we don't do that, there could be a scenario where we kind of did a great marketing campaign and put the product out there and told thousands of customers, but then when you start working on it, suddenly you hit the ceiling, and then no one is here to help, and that can happen for sure. That is a inevitability as far as the capacity is concerned. So proactive work will really help. Second one is the cost. So like I said, in the previous example, there's a good possibility that cost can go up very exponentially, mainly because if you're using OpenAI or any of the token-based systems, the traffic can actually go up depending upon how the customer is using as well. Once we put it out, in the traditional SaaS product scenario, it is very predictable. So I put out a feature. For example, this feature is creating an article generation. It does exactly what I expect it to do, depending upon what customer inputs. Right. In the case of generative AI, outputs could vary depending upon customers' inputs, and then that is
Yep.
completely not in your control. And that's exactly why we are looking at modular system where you are continuously monitoring it through your MLOps and be able to either switch the models, because there could be two models which are, there's a model which is costing you $1, other model could be costing you 10 cents, 10
Yep.
times difference, but there could be 20% reduction in the quality. I should be able to just switch to the next one if there is need be. And third one is performance. I think we should continue to look at the performance, and performance model drifts can happen. Same model which has been operating great until last week, and I did a small deployment and with the small prompt changes, and then suddenly it starts, behaving so from milliseconds to it went to seconds. So continuously look at performance as well, and see how we can benchmark and improve on that as well.
Interesting. So now on the first point, right, where you have to earmark the GPUs and put it right. Who would have thought in a cloud world that you have to do this? Because this reminds me 10, 12 years back at Yahoo and all, you will have to actually plan the capacity of like how many filers you need and how you want the number of CPUs and all those things. We thought like it's unlimited. And today now you are going back and saying like, oh, next 18 months, I have to forecast and put that one, right? It's a very interesting stuff
Yeah.
that in a cloud world you wouldn't have imagined that you will have to actually forecast that part of it. On the second aspect, when you said that the models, you will have to keep checking the models performance and all those things in your platform engineering, are you also continuously evaluating other models to make sure that, hey, this model, like A/B testing kind of stuff, hey, by the way, this new model is starting to perform better, so let me switch this part. Do you do that? Like how do you
Absolutely.
know? Okay.
Absolutely, yes. So there is a continuous evaluation of models happening as part of model governance that we have. And if I were to portray this, there are three different layers. Layer one is my development environment, or I would say R&D. Layer two is my staging environment, where it's a little more restricted, where use cases are running on it. Layer three is my production environment. So if my production environment has five use cases using one single model, which is a very good possibility. Same five use cases may be using five different models in my R&D.
Yeah.
That's yeah. So and we are looking at certain parameters like functionality, round trips, accuracy, and bias, temperature. All these different parameters that are there, they are being benchmarked simultaneously as we speak. And from R&D, the five models will become probably two models in staging, and they'll become one model in production. And this modularity is a kind of helping us tomorrow. The model that is in production is for some reason either not cost effective or drifting. I'll be able to plug in another model without changing too much in terms of functionality.
Awesome. Awesome. I think we have got few questions, so let's go to that. I think we took a part of the first question.
I have one
Organization.
couple strategies to share, Satya, if that is okay.
Yeah, sure. Yeah, 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 yeah.
Yeah. So this is probably the bonus part, and I'll spend 5 minutes here for folks who are
Sure.
here. Is that these are innovative strategies. It came up over time, I think, over maturity, and we learned this the hard way. Is one Number one is generative AI versus discriminative AI, right? Or you can think about large language models versus proprietary models. So every company, if you are looking to scale, keep these two options with you, where your use case should be able to run in both. One example, if I am doing a article generation as a technical article generation as a use case, I should be able to generate it using GPT 4.0 from OpenAI. Also have a Llama 2 running on my GPU machines as well. Now, why this is important is because whenever you see that the cost is either running away or there are drifting or there are multiple other parameters that are happening with the token based system, you'll be able to pull it back to your discriminative AI, proprietary AI, and then that will actually keep your business sane.
Yeah.
Otherwise, we are at the mercy of the model's behavior. Right? That's one. Number two is a dual deployment method. This is slightly related to the first one, which basically means that I want to be able to create that CI/CD pipeline in such a way that I'm always in most important use cases, I'll be able to deploy in these two environments, two different models, and only one goes into production, but other one continues to get maintained. Third one is the iterative model of pipeline we are talking about. There are multiple both the discriminative proprietary GPU based models running, and then the token based models running, and there is a dedicated team who's continuously testing and benchmarking these systems and publishing it. So as a developer, I suddenly have a use case today, and then I have to develop it. First, I'll go and look at my model garden and look at the benchmarking, and then I'll be able to actually pick up my top and second top picks for this as a models and be able to actually deploy them. So these are the couple of strategies, or I would say innovative methods we can think of. Basically, they'll bulletproof your business, so that just in case if something very interesting happening with the models, you are still be able to protect your business.
Awesome. Thanks, Sridhar. I think
Yeah.
let's go over the questions in terms of. I think organizations want to modernize their application at affordable cost. Practically speaking, how should we make utilize Gen AI in this scenario as well?
Yeah. No, absolutely. I think cost is very very important for companies these days, and end of the day the top line and bottom line is very very key for us. So generative AI in many ways, right? To start with, it'll look expensive. It is expensive, especially GPUs are not cheap, and also the token based systems are not cheap. And this is where our data scientist skill is coming out, is that hey, in a medium to long term, so if I look at the 12 to 18 months period, when obviously business is going to be around, company is going to be around, or when I'm going to break even, if I use this generative AI, where I'm going to slightly add to my cost, slightly add to my overheads here, but then definitely will reduce the amount of hiring I need to do, amount of developer investments I need to do, and probably add more value to my customer. So which means I'll be able to monetize or even add cost to the offer to the cost back to the customer. So if you slightly look at a longer horizon, 12 to 18 months, if you should definitely be able to see a good ROI and a break even there. And if you're not seeing that, then probably that's not the right use case. But either way, world is going generative AI way, and it's important, it's imperative that all of us actually continue to look at it. And you already see multiple different industries. There's pharmaceuticals, there's a insurance industry, the FIS industry, tech for sure, travel, tech. Each of these industries already found compelling use cases for us to break even within 6 months.
Well, and is that when you talked about your you need to know the use case and then what's the cost of it, right?
Yeah.
Is that a prediction that you will do? Like, okay, here is the cost of it. Like, get to the unit economics of what that particular transaction is going to cost, and how much am I going to make out of it, right? Is that the way you would do it?
Yeah, it's a combination of prediction and also the real-time testing. So I would generate test data that I would get probably 6 months later in
Hmm.
my staging environment, and try to load my LLMs and see how they behave. One, and the second thing is that if this happens, how many tokens are getting generated? What could be the cost? So I could run it for 5 minutes, but then extrapolate it to 1 month, and that gives me a tentative the performance cost that can happen, and then based on that I can also come up with pricing strategies.
Got it. Got it. And the next question: what if do you think AI is going to make sure that we have more quality model and human-like behavior that is impossible? So,
um, so I think this goes to slightly towards the governance part of it, right? So the AI models today, at this point at least, they are depending upon their quality totally is depending upon their training data. If it is an industry vertical model or generic model, right? And at this point, a human like behavior is not possible, right? But we cannot rule out that possibility sometime in the future. So it all depends upon who is governing it and how they are governing it, kind of scenario. So right now, in many ways, they are able to mimic human behavior in many ways, but we are hoping that it is for the right or a good thing.
Yeah, I think just adding to that, I think there are areas in which it can mimic, right, in a particular stuff, like it's able to
Yeah,
understand emotions a bit, or it can say that how good did you speak kind of stuff. But again, human brain is far more advanced to perceive so many things that maybe it will take some time. But again, as it's catching up, maybe we will have to see how it is, right? What are few
absolutely.
met-
Yeah,
go ahead,
go
sir.
ahead. No, no.
What are few metrics you recommend we should monitor when deploying public and private models together to address a given use case, and why?
Yeah, no, I think this is a great question. So these metrics that we are talking about is some of them are automatable, which means that machine-based metrics, and some of them are more like a human oversight dependent metrics. The automatable metrics that you can looking at is the by product, by use case. We basically measure number of tokens that are going in and out, okay, and the cost, so the model that we are using for it, and then the cost. So these are the three. It's a nice triangle. It's a cost, use, number of tokens, and the model that is being used. So any of the one variable that you change, the outcome will actually automatically change, right? And then performance round trips for every prompt that is going in and coming out. And also that if you have a system, governance system, that is talking about fairness or bias, you have to see how many prompts are being dropped because they detected this content, this type of content. So out of every 1,000 tokens that you're going in, like maybe 10 tokens are getting dropped. And if you also have a system that actually continues to look at, if you have also a system that has caching mechanism like a vector database, you'll also be able to detect the hit rate, of the that particular vector database. How many times I'm serving from cache versus how many times I'm going to LLM actually coming back. That's another metric. There are situations, for example, if you're using it for developer productivity, okay, and when a developer is using for either code generation or code completion, test case generation, they each time they ask for a code completion, and then the LLM gives you code completion. They basically say they accept the code, for example. Okay, it's
Hmm.
a acceptance rate. You can track that as well. If the acceptance rate is like less than 20-30%, then probably it's not being effective. If it is more than 30, 40, even 50%, then it's actually accurately generating and developer is accepting it, kind of thing. So these
Yeah.
are some of the.
And do you also look at how long does it take to generate it? Because again,
Yes,
it's a perceivable time, right? Like if it takes 10-20 seconds, I would rather write it. Like, is that something you measure, that
absolutely.
what's the time taken for doing this?
No, absolutely. And then it also depends. For example, if I'm looking at some kind of offline reporting, I'm okay to wait for 10-20 seconds versus some real time. I'm on a chat bot and I'm actually looking for a real time response and it takes in 10-20 seconds. I would go for competition. So definitely we should look for, it's also tricky because, and some of these cases only you see in scale is most of the times when you test it with the smaller payloads.
Yeah.
So I'm sending like 100, 200 tokens and they're coming back. And the customer probably just uploads an entire wiki page of 20,000 lines, and then it takes like 10 minutes for it to come back. Um, it's purely depending upon how the LLM also is behaving at the end, because there are certain glass ceilings that they are there. So yeah, you're right.
Awesome, Sridhar. I think with that, I think we are coming to today's episode's this one closure, and then I think next week we are going to talk about governance. Right now that we talked
Yes.
about the use cases, and now we spoke about like how are we going to scale. In the
Yeah.
next week, we are going to actually look at, okay, now you are running, but how do I govern these models? I think it'll be an interesting one. Thanks a lot, Sridhar. Pleasure to have you here.
Absolutely. It was great talking about bootstrapping and then about scaling. Now it's about how to protect our businesses so that something wrong will not happen
Yeah.
with AI and all that interesting topics. So looking forward to being the third episode as well.
Awesome. See you. Thanks.
Thanks, everyone.